Last class, I have forgotten to give or to discuss two questions already asked here. Here's our examination. First, we will see that two questions related to the enhanced equation. Then we will go for the next application of the electrode potential, the last application of this electrode potential. Then we move towards the concentration shapes and take on the problem that has been asked. The correct value of epsilon naught, the correct value of epsilon naught of a half shell in the following graph, in the following graph. Following graph of epsilon versus log of m. M is nothing but molality. Molality is take down the graph is a 0. Log of 1 is equal to 0. We have already seen yesterday, and it is this equation is drawing towards this one. This is the graph given. This is C dotted lines, C prime. This is B, and this is B prime. And here the epsilon is going on increasing. And the line cutting the minus x-axis at the point A. This is the graph given. Last class we have seen this epsilon is equal to epsilon minus something according to Nernst equation is not. With respect to that equation, here a problem is given. Here, what is the E naught value, epsilon naught value? You have to give the answer. That answers provided by them is C prime divided by AC prime. B option, AB prime. C option, B prime is there, epsilon naught, and D option, C prime, which is the correct answer. Yesterday itself I have told you the epsilon naught is this part of it, I have told you. That is what is epsilon naught? That is a standard state. At standard state, the concentration of the electron should be 1 molar. Log of 1 is equal to 0. Therefore, epsilon value will be that E value at which the log of m is equal to 0. Therefore, what is the correct answer?
C.
The B prime. This is nothing but epsilon naught. Therefore, this is the correct answer. This is the question already asked. And another question is, take down the question and then I will give the method or procedure to calculate this. You yourself understand the problem immediately. Calculate the equilibrium constant. Calculate the equilibrium constant for the cell reaction. For the cell reaction. 2Ag plus Zn with reversible arrow, giving 2Ag plus Zn2 plus. Occurring in zinc silver cell at 25 degrees centigrade. When the concentration of zinc 2 plus is equal to 0.1 molar and concentration of Ag plus is equal to 1 molar, full stop. The EMF of the cell, EMF of the cell is found to be 1.62 volt. This is the problem given. Calculate the equilibrium constant. This is the problem asked. Option A, 1 into 10 power 54, B, 8.1 into 10 power 52, C, 4.9 into 10 power 53, D, 1.8 into 10 power 51. Here the equilibrium constant value is given in the numerical value. Therefore, you have to find out this value in terms of the numerical value. And what is the formula to be used? Log K is equal to N into FZ naught by 0.06. This is for getting numerical value. Okay. After arriving at that, you have to find out the anti-log. For the, if it is given in terms of power of 10, then it is equal to 10 power E naught by 0.06. Any one method you can easily find out N of E naught, 10 power 0.06. Here the equilibrium constant is given only under standard condition. Therefore, for calculating K, you should make use of the E naught, that is the cell voltage at standard condition. But here the EMF given, whether it is in the standard condition or in a non-standard condition, for which what we have to look for, look the concentration terms. For a standard condition, the concentration terms would be 1 molar. Here the silver concentration is 1 molar, but zinc concentration is 0.1 molar. Therefore, this condition is not the standard condition. Temperature 25, therefore it is in the standard condition. But the concentration of the electrolyte is a different, therefore it's a non-standard condition. Therefore, the EMF given is a non-standard condition. Now, what is the task present before you? You should not E value for calculating K. You should use the E naught value for calculating the K. What is the relationship between the E under non-standard condition and E naught? That is Nernst equation. You know the right. You can write down the Nernst equation as E is equal to E naught the cell minus the 2.3 into R into T by NF into log of the concentration of the reactant side or activity of the reactant by the activity of the products, product divided by concentration, reactant, power 2. This is the equation you have to make use of it. Here the concentration of zinc 2 plus is given, silver 2 plus is given, and it is a T is a standard condition. Under this condition, you know the value of this one. I'm sorry. You know the value of this one under standard condition. That is nothing but 0.06. Therefore, you can write this as E0 cell minus this is equal to 0.06 by N into log of concentration of zinc 2 plus is 0.1 divided by concentration of silver is 1 power 2. What is N? Number of electrons involved in the cell reaction. How many electrons are involved in the cell reaction? 2 electrons. Therefore, put the value for N2 and find out the log of 0.1 and everything. Now you can calculate the E naught of the cell. After calculating E naught of the cell, you can calculate this one. I think it is sufficient to find out the 10 exponents of this power, 10 power value is sufficient to arrive at the correct answer. Therefore, do this calculation in your phone. Next, we will go to see the last application of this electrode potential. The last application of this electrode potential is it is stability of a given oxidation state. Stability of a given oxidation state can be predicted, can be predicted from the electrode potential values, can be predicted from the electrode potential value. I will first explain what is the stability of an oxidation state. And if it is unstable, it will go to give what products it will give. First, we will discuss, then we will give work out some problems in this. For example, consider uh, the Latimer diagram for manganese species. The manganese is existing from 0 oxidation state to +7 oxidation state. The +7 oxidation is the permanganate, and the next is the +6 oxidation state that we call it as the manganate, and the next to this one is the 4 plus oxidation state, MnO2. Here it is present in the +2 oxidation state, and the next +4 oxidation state. Next is the manganese in the +3 state, manganese in the 2 plus state, and manganese in the 0 state. I have told you that in the Latimer diagram, it gives only the reduction potential value. In the left-hand side, you will be starting with the highest oxidation state of the given species and ending with the lowest oxidation state of the species. And here, the electrode potential MnO4 minus to MnO4 2 minus, that is when +7 state is converted into +6 state, the electrode potential involved is 0.56 volt. And then the +6 to +4, the potential value involved is 2.26 volt. And +4 to +3, 0.95 volt. And 3 plus state to +2, 1.51 volt. And +2 to the manganese 0, it is minus 1.18 volt. And it is the direct one. And you may be also be given, if it is converting in +7 state to +4 state directly, then you should put the arrow from here to here. The potential involved is 1.7 volt. Similarly, when +4 state is directly converted to +2 state, directly converted to the +2 state, and you can write down the arrow from +4 to +2 state, and the value is 1.36, and in our permanganate titration, you may come across this one, manganese from +7 state to directly converted to +2 state. If it is there, then the electrode potential is going to be 1.514. These are the Latimer diagram giving a simplest way what are the potential existing between when one oxidation species is converted to another oxidation species. We call this a Latimer diagram. Simplest way of representing all the possible electrode potential of a given species in different oxidation state. Here, which species are unstable? The question is which species would be definitely or may be unstable or may not be unstable. For your information, the species present at the two extreme, that is left and right, will not be undergoing any further reaction. They are all stable. In the given example, the permanganate is the left hand side, that is +7 oxidation state, and manganese metal is in the left hand side, right hand side, 0 oxidation state. These two states are more stable. They won't undergo, they are not unstable. Then which species may be undergoing unstable, having unstable nature? The species in between them. Here, what are the species present? Manganate, that is +6 state. The manganese dioxide, that is +4 state. The manganese in the 3 plus state, +3 state. The manganese in the +2 state. Extreme 0 and +7. The extreme states are stable. They are not going to, they are not to be unstable. These are the intermediate states may be unstable, of which is definitely unstable species. If it is unstable, it is undergoing to what species it may be forming. For example, now let us consider the manganese 2 plus, the manganese 2 plus or manganese 3 plus, let us say manganese 3 plus. It may be unstable means it may be going to reduce its oxidation state to Mn2 plus, or its oxidation state may be oxidized to the nearby manganese 4 plus state, that is Mn O2. If a species undergoing the same species undergoing oxidation and reduction, in organic chemistry we call this auto-oxidation reduction reaction. The aldehyde undergoing reduction to give alcohol and acid, auto-oxidation reduction. In inorganic chemistry, one oxidation state is the same oxidation state undergoes oxidation to higher oxidation state or undergoes reduction, the same oxidation state undergoes reduction to the lower oxidation state. Then this reaction is called as disproportionation reaction. In organic chemistry, we call it as the disproportionation reaction. In organic chemistry, we call it as the auto-oxidation reduction, disproportionation. Therefore, the question is, among the following species, which is undergoing, which is unstable, or which is undergoing disproportionation? The question is, it is unstable means it is undergoing oxidation and reduction. That is, in other words, it is undergoing disproportionation reaction. The reverse of disproportionation reaction is called comproportionation reaction. Comproportionation reaction. Reverse of this comproportionation. What do you mean by comproportionation reaction? If you just reverse the definition for disproportion. In the definition of the disproportion, what we have to one oxidation state of a species undergoes oxidation to higher oxidation state or undergoes the same species undergoing reduction to lower oxidation state. It is called the disproportionation. Disproportionation. Two different oxidation state of a species. Two different oxidation state of the species. Combinedly give rise to a species of intermediate oxidation state. A species of intermediate oxidation state. Then we call it as comproportionation reaction. Consider this reaction in the reverse manner. That is manganese 2 plus undergoing oxidation to give Mn3 plus, and the nearby higher oxidation state +4 undergoing reduction to give the same Mn3 plus. Here two different oxidation state of a species undergoing oxidation as well as reduction simultaneously to give a species of intermediate oxidation state. 2 plus, here 4 plus, there it is having the oxidation state 3 plus. Then this reaction is called comproportionation reaction. Therefore, the stability of the oxidation state can be predicted if the electrode potentials are given. This is whether it undergoes disproportionation or not. Now we will have a problem and we will discuss it and you will easily understand this. Then after that, we will see, look into that, how to identify the unstable species just looking into its potential. First, we will see it in terms of systematic procedure. Then we go for the shortcut method. And given the epsilon naught value of gold for gold plus equal to minus 1.68 epsilon of gold plus for gold plus equal to minus 1.28 volt and epsilon of iron 3 plus bar FeO4 2 minus, sorry, 2 minus is equal to minus 2.2 volt and epsilon of iron 2 plus for iron 3 plus is equal to minus 0.77 volt. Which species, which species is unstable? Pick out the or take down, pick out the correct statement from the following. Pick out the correct statement from the following. Au plus and iron 3 plus are unstable. B. என்ன ஆன்சர் கொடுக்கலாம் அடுத்தது? Au plus is unstable. Comma, iron 3 plus is stable. What is the another answer? C. Au plus is stable. Iron 3 plus is unstable. And the last distracted is both Au plus and iron 3 plus are stable. Which is your answer for this. Here we are going to give the systematic method, then we apply it with the shortcut method. First step, we will take this one. What are the oxidation state given in this electrode potential values? Gold is in the 0 state, gold is in the +1 state, gold is in the +3 state. Therefore, if you see this, which state, for which state you can find whether that oxidation state is stable or unstable of the 3 states. The extreme states are stable, the asymmetries are stable. Therefore, for which state you have to find out whether it is stable or not. If it is a stability means whether it undergoes a disproportionation reaction or not. If, under this condition, you write is like this. Au plus, let us assume it is unstable. Au plus would be reduced to give Au 0 and Au plus would be oxidized into Au 3 plus. To find the stability, you are need of the reduction potential Au plus to Au 0 reduction potential. You are need of the oxidation potential Au plus to Au 3 plus. given the oxidation potential minus 1.28 volt. But the first one is the oxidation potential, but we are in need of reduction potential value. Therefore, convert the sign and add these two potential. Adding these two potential, you will get 1 plus 68, 1.68 minus 1.28. Definitely, the resultant epsilon value is equal to positive. When delta E naught is positive, delta G is negative. When delta G is negative, that reaction is feasible. That means AU plus is unstable. It is undergoing reduction as well as oxidation. Or in other words, it undergoes distillation. For how and what is write down the sequence oxidation, reduction, and reduction and find out the corresponding oxidation potential and reduction potential. Sum of these two potential, what is the net E is the epsilon value. If it is possible, the reaction is possible. If it is negative, epsilon zero is negative, the reaction is not possible. Therefore, from this first itself, AU plus is unstable. AU plus is unstable, AU plus is stable. Here it is given, therefore, this answer is not possible. Therefore, next you go for calculating for ion oxidation state. Similarly, here find out which oxidation states are given in the extreme condition or which states you are going to see this one. Iron 3 plus state, iron here. What is the oxidation state of iron here? Anybody? Oxidation state of iron. What are the oxidation state given? Plus 2 is given. Plus 2 given. Plus 3 given. Here, what is the oxidation state?
plus
Plus
6.
plus 6. Therefore, according to our calculation, plus 2 and plus 6 are stable. If at all, which species would be undergoing the disproportionation? Iron 3 plus. Iron 3 plus undergoing disproportionation as iron 3 plus 2. Iron 2 plus reduction and iron 3 plus 2. FeO4 2 minus oxidation. You are in need of oxidation potential. The oxidation potential is given as minus 2.2 volt. You are in need of the reduction potential, but here it is given as the oxidation potential. Change into reduction potential. Sum these two potential, you will end up with epsilon naught value positive or negative. Epsilon value
Negative.
negative. Epsilon value negative means that reaction would not be taking place. Therefore, that means iron 3 plus is stable with respect to disproportionation. Therefore, iron 3 plus is stable, whereas AU plus is unstable. Therefore, which answer is the correct answer? Which answer is the correct answer?
Option B, sir.
Option B is the correct answer. In this way, we are doing this. And is there any shortcut method? Is yes, there is a shortcut method. Is there? What is the shortcut method? I'm going to give you the shortcut method. If you find the methodology so far adopted as easier, that is the systematic procedure we have adopted is easier, you go by this. Or there is a method by which you can also see that this is very easier, and for which you have to give this EMF value in terms of Latimer diagram. In terms of Latimer diagram. The Latimer diagram, the highest oxidation state is written in the left hand side, and then next intermediate is A plus, and the lowest is written here. Here AU 3 plus giving AU plus giving to AU 0. Here what is the reduction potential value? 1.28 volt. What is the reduction potential value? Plus 1 point, sorry, here minus, therefore reduction potential 1 point. and it is 1.68 volt. Looking into this diagram, you can say that Au plus is unstable. How, sir? I will tell you. Similarly, now write down this next one, FeO4 2 minus, giving Fe3 plus, giving Fe2 plus. Here you have to, this is a Latimer diagram, Fe plus 6 to Fe3 plus. Here, but it is given in the oxidation potential value. Here, need of reduction potential, therefore 2.2 volt. Iron 3 plus to iron 2 plus. Here, oxidation potential value minus 0.77 is given. You convert it the reduction potential value plus 0.77. And looking into this Latimer diagram, how would you prefer, sir, that it is stable or an unstable? The secrecy lies in the way. Look out the reduction potential value of Latimer diagram from left hand side to right hand side. If you have a look out, take down the permanganate series, the highest oxidation state to the next one is 0.56 volt, 0.56 volt. Next, plus 6 2 plus 2, the value is found to be 2.26 volt. The value is somewhat increased. Then 2.26 volt to next one, 0.95, the value is decreased. And then next one, the value is increased. Next one, the value is decreased. Generally, when the reduction potential value gradually decreases from left to right, then all the intermediate species are stable. No species would undergo disproportionation. How to identify by looking into the Latimer diagram, reduction potential value. Look out that reduction potential value, start from left, go to right, and what about their sequence? Whether they gradually decreases, then you can say all the intermediate oxidation states are stable. If you work out this with the systematic procedure, you will end up with that. And whenever or wherever this trend gets ruptured, now the slow, it should be going on decreasing slowly. But whenever or wherever it gets ruptured, the species present at that place undergoes disproportionation with respect to the species present on both sides. That is unstable and it undergoes reduction to the next species and it undergoes oxidation to the previous species. And keeping it in mind, now let us have a look into this one. Look into this one. Here, let's start from late 1.28 volt. Here you should be going on decreasing. And what about the next one? 1.68, it is increased. Therefore, the trend is ruptured here. And which species is present in the which species is present in that one? Au plus is present. Therefore, you can say that Au plus is unstable. What we have calculated also indicates Au plus is unstable. Now we go for the next one, the iron system, 2.24 volt and 0.77. It is gradually decreasing. The trend is not ruptured. Therefore, you can boldly say that iron plus is stable. If you are well acquainted with this, now you give the answer for the next two problem, and with that we will finish our application of this electrode potential. Take down this problem. Given the Latimer diagram, I would import it. Take down the manganese. Just now I have given this one Latimer diagram for the manganese species. Then continue the question. Which species of manganese are unstable? A. MnO4 2 minus and Mn2 plus. B. MnO2 and Mn3 plus C MnO4 2 minus and Mn3 plus D MnO4 2 minus and sorry, not MnO4 and Mn3 selection MnO2. Which species are unstable? First thing, the extreme species would not undergo any disproportionation. Therefore, in the answer, whenever in this answer, what are the extreme species present in our case? The permanganate and the manganese. If at all given in the distracted, first is remove that distracted. Not possible. Therefore, which species are maybe unstable? Plus 6, plus 4, plus 3, plus 2. For which find out the sequence of the trend, sequence of the redox potential value sequence, and in which cases it should be going on slowly decreasing, where that trend is ruptured, that species is unstable. Therefore, what is the correct answer for your correct answer for the questions?
Option C.
Option C is the correct answer. How? 0.56. Here, the next voltage reduction potential is found to be increased. Therefore, here this is trend is ruptured. What is the species present in between the rupture, the permanganate? Therefore, it is definitely unstable. Therefore, this is not the answer. Okay. Then MnO2, 2.26 volt and 0.95. It is decreasing. Therefore, it is not violating. Therefore, MnO2 is stable. Therefore, this is not the answer. And then 0.95 giving one, next one is 1.54, increases. The trend is ruptured and what species is present? Mn3 plus. Therefore, this is the correct answer. And next one, 1.51 and next minus 1.8, decreasing the trend. Therefore, Mn2 plus species is stable. Therefore, of the four species of the intermediate of the manganese species, two will be stable, two will be unstable. This is the method by which shortcut you can easily find out the answer. Next, one exercise to you. Given the Latimer diagram, take down the diagram. Ag2O3 solid giving Ag2 plus aqueous 1.36 volt, then giving Ag plus aqueous 1.98 volt and giving silver 0.8 volt, then Ag2O32 Ag plus 1.67 volt. Here, why we are giving this one? What about the stability of Ag plus? Whether it undergoes disproportionation with respect to silver and silver oxide, that is the plus 4 oxidation state. Sorry, the plus 3 oxidation state, for which you have to take this and this trend. This and this, there is a decrease. Okay, therefore Ag plus is stable with respect to Ag2O3 and Ag, you can say like that. The question is, which of the following statement bracketக்குள்ள is statement bracketக்குள்ள yes போட்டுக்கோங்க is bracketக்குள்ள are correct? Which of the following statements are correct? A, first option A. Ag2 plus is unstable. Ag2 plus is unstable. with respect to, that is, it will be converted into Ag3 plus and Ag plus. B statement. Ag plus is unstable with respect to Ag2 plus and Ag. C. Ag plus and Ag2 plus undergo comproportionation. Comproportionation. தப்பால போட்டிருக்கோம். Ag, here put it like this. Ag is 0 and Ag2 plus undergoes comproportionation to Ag plus. Comproportionation to Ag plus. D option. Ag is 0 and Ag3 plus undergo comproportionation to Ag plus. Comproportionation to Ag plus. Okay. Next, option A. A only, the statement A only is the correct answer. B, A, C, D, C option, B, C, D, D option, A, B, C, A, B, C. Which is the correct answer? Go and check in your home. With this, we finish the what we call it as the applications of the electrode potential. And now we are going to see the concentration shell. What do you mean by a concentration cell? Concentration cell. This is also a voltaic cell, but here the voltage is produced in what way? Before seeing this concentration cell, we will have the conditions for this electrode potential or the cell EMF. The cell EMF depends upon three parameters. What are they? We have seen, that is the activity of the electrode or nature of the electrode. What electrode we are making use to construct that cell. If their electrode potentials are different, we are getting a voltage, very high voltage. If their electrode potential values are very nearer to each other, we are getting a feeble current from the light. Therefore, the cell EMF depends upon the activity of the electrode. And the second thing we have seen is the concentration of the electrolytes. Concentration of the electrolytes in which the electrodes are big. Therefore, it is necessary for us to define a standard state. The concentration of the electrolyte should be 1 molar. And the third factor is the temperature of the system. The temperature of the system means the temperature changes, the EMF changes. The EMF changes. Therefore, based on this, the temperature of the both the anode and cathode are same. Let us having this one, and the concentration of the electrolyte is also made same. We will change the electrode activity difference, or how would you change the electrode activity difference? By taking the same electrode, but it is having a different activity. How it's are possible? I will tell you. I am taking this. This is a H plus ion acid of 1 molar at concentration. In the cathode compartment also, I am taking H plus ion 1 molar concentration. Here I am passing hydrogen, passing hydrogen. Here also it is a hydrogen electrode and I am passing hydrogen. Here H plus concentrations are there. And here also hydrogen electrode activity are same. Here the electrode activity, we are going to change the electrode activity. How? For standard state, we are using the hydrogen pressure as 1 atmosphere. Here, I am not going to use 1 atmospheric pressure hydrogen. Instead, I am going to use zero point 0.8 atmospheric pressure. Now, the two electrodes are same, but their activity here, whatever activity is one equivalent to 1 atmospheric pressure. Here we call this the fugacity. If it is a gas, we call it not at the activity, we call it as a fugacity. The fugacity of hydrogen 1 atmosphere is different from the hydrogen in the 0.8 atmosphere one. Therefore, we are keeping the temperature constant. Here also it is say 25 degrees centigrade. The anode compartment also 25 degrees centigrade. The two conditions are maintained, but one condition's activity of the electrode is not maintained. If it is not maintained, whether there is a difference in the electrode potential or cell EMF, definitely there will be a difference in the electron cell EMF. And that is sufficient for us to derive EMF from the cell. Here the cell is due to the difference in the activity or the electrode. Here as usual you should join externally and you should put a salt bridge. Then whether current is flowing or not. Yes, current is flowing from this to that one. And which is forming the anode, which is forming the cathode. Here, hydrogen, both are hydrogen, one is in the cathode and which is in the anode. Which hydrogen would act as the anode? Which hydrogen would be acting as the cathode? For which, from based upon the Nernst equation, we can derive one equation that is epsilon, sorry, the E is equal to E naught minus what we have written 2.3 E naught into R into T by N L into log of the concentration of the product by concentration of the reactant. Here the concentration of the இது வந்து எது வரும் hydrogen at 1 atmosphere giving cell reaction. I am going to write as H plus electron, half hydrogen giving this one. And another here we will have not 1 atmosphere, let us have it say A1 atmosphere. In the other reaction, H plus would take the electron, giving half hydrogen, that is cathode reaction. Here activity is A2. If you join together, you will write down the activity of hydrogen here and here are same. This and this cancel. Therefore, the next reaction half H2 activity is A1 and half H2 the activity is A2. Or you can cancel half to activity A1 and activity A2. Here we are having the anode activity, the reference side A1 and the cathode as A2. And if you could substitute, this is the product side A2 by A1. A1. Okay. And here, what is E naught? Here also hydrogen standard. Here also standard hydrogen electrode. The electrode potential for this way, you write it as 0, and for the cathode it is -0, 0 minus 0 is equal to 0. Therefore, E naught would be 0 for a concentration shell, always is 0. Here, if you take, instead of hydrogen, if you take nickel rod in one side, dipped in nickel 2 plus of 1 molar, and on the other side, nickel dipped in nickel 2 plus 1 molar, its E naught value, are same. Therefore, the cell is E naught would be equal to 0. Therefore, for concentration cell, always the E naught is equal to taken to be 0. And therefore, we have in the start of the electrochemistry, we have seen the E naught is equal to positive spontaneous reaction, E naught is equal to negative. It is a non-spontaneous reaction, E naught is equal to 0. It is an equilibrium reaction. With that, you can add one more. If E naught is equal to, it may be a concentration shell. Why we call this a concentration cell? Here the cell EMF is derived because of the difference in the activity of the electrode. Since particular, it is generally called as concentration cell, but the concentration difference is due to what? The electrode. Therefore, it is specifically called as electrode concentration shell. The electrode concentration shell, the electrolyte concentration would be same, but the electrode activity would be different. In the electrode activity different, one is having higher activity and another is having lower activity, from which is acting as the anode, which is acting as the cathode, for which we are seeing the answer for this, for which we have derived this equation. Seeing the equation, you can easily say this one. Therefore, for any concentration cell, E is equal to, this is becoming 0, therefore minus, if it is a standard condition, that is T temperature in the 298, we call it 20.06 into N into log of A2. A2 is the is the activity of the product, that we call it as the which side, anode side or cathode angrada paatharala, and this one A1. And when will the E value would equal? What would be the case? When the activity of A1 and A2 are same, activity of A1 and A2 are same, then the quotient would be becoming, when quotient is becoming 1 means log of 1 is equal 0, therefore E would be 0. That is, its activity 1 atmosphere, heat activity 1 atmosphere, and the electrolyte concentration 1 and 1. No electricity would be produced. Therefore, there should be a difference in the concentration of the electrode. And when, at what concentration, the E value would be positive. E value would be positive, for which the log value என்னவாக இருக்க வேண்டும். The quotient value, how much would be the quotient? The quotient value we have seen, it may be greater than 1. When will it be greater than 1? A2 is higher than A1. Quotient value is 1, greater than 1. Log of greater than 1 is a positive value, and such cell will be having a negative value. No electricity is produced. Then when will electricity would be produced? The Q value is less than when the quotient value is less than when. For the quotient value less than when, the activity A1 should be greater than A2. Then it will be becoming, this A2 is less, A1 is higher, then it is becoming a fraction. Fraction of logarithm of a fraction is negative. That negative, this negative would be becoming positive. Therefore, for the electrode concentration cell, we can write the equation as log of A1 by A2. A1 is higher concentration, A2 is lower. Look at the change, look at the difference. This would lead to the negative value to positive value. Therefore, if you want to derive EMF, your the activity, higher activity electrode should be kept as the anode. Higher activity electrode should be kept as the anode. Lower activity electrode is kept as the cathode. Now, in our diagram, what we have drawn, whether EMF would be positive or negative, look at the diagram, find out whether it's a positive value or negative value. Anybody, whether it is a E value of that electrode concentration cell is positive or negative. For which positive value, the activity A1, this is the A1 and this is the A2. A1 should be higher, A2 should be lower. And here 1 atmosphere higher activity, 0.8 lower activity. If this is the situation, this would be acting as the anode and the electron is moving from these two and electricity is produced. Therefore, just looking into the diagram or in the representation, cell representation, whether the electrode potential, I'm sorry, electrode concentration cell will deliver the EMF or it will consume the EMF. You can easily say this. This is called concentration cell of two types. One what we have seen is called electrode concentration cell. Concentration cell is of two types. One is electrode concentration cell. That is here the activity of the electrode are different. And another is electrolyte concentration cell. And the name itself indicates the electrodes are having same activity, but the electrolyte would be having different activity. That is the difference between the electrode concentration cell and the electrolyte concentration cell. How would you identify this? Easily identify, suppose one is given as like this, hydrogen, 1 atmosphere, bar, Hg plus, bar, hydrogen, 0.8 atmosphere, and platinum. Whether it is a concentration cell is not, whether it is a concentration cell or not, find out. If it is a concentration cell, to which type it belongs, electrode concentration cell or electrolyte concentration cell. Here, look out this into this. Here, the same Hg plus ion, hydrogen 1 atmosphere is passed, the same hydrogen plus ion, hydrogen 0.8 atmosphere is formed. Generally, we should write this equation like hydrogen, this representation should be normally written as Hg plus, say 1 atmosphere, 1 molar, double salt bridge, Hg plus 1 molar, and in which hydrogen is passed at 0.8 atmosphere. And concentration shell means of two types. One is the electrode concentration cell, another is the electrolyte. Whether it is an electrode concentration cell, look into the electrolyte, their concentrations should be same. And the electrode activity should be different. They would be the same electrode, but their activity would be different. Here 1 atmosphere and 0.8 atmosphere. Therefore, the representation indicates which concentration cell. First, you find out whether it's a concentration cell or not. Definitely, it's a concentration cell. Whether it's a electrolyte concentration or electrode concentration, it is an electrode concentration because electrolyte concentration is the same. And in order to write this repeatedly in a lazy manner, they may write it in a single way. Therefore, these two are representing one and the same. Okay, sir. Here, hydrogen gas is passed Therefore, I can change its activity. If a solid is present, for example, zinc, I am taking a zinc solid and zinc sulfate, I am dipping in a zinc sulfate, 1 molar. I am taking another cathode zinc sulfate, 1 molar, and zinc solid I am dipping in this. Sir, how can construct a electrode concentration cell using this type of metal electrode? Yes, we can change the activity of the zinc present in both the case. How it's sir? Convert into amalgam. Convert into amalgam. For example, 100 gram of mercury is taken, in which only 2 gram of zinc is added. 2 gram of zinc is added. Now you get a zinc amalgamated in which the amount of zinc present is only 2 gram. And another electrode, I am adding 4 gram of zinc in the same 100 gram of mercury. Here also zinc amalgam is present. And if you connect this, whether we are having the same activity of zinc in both the cases or different cases, tell me the answer. Hello? Same activity or different activity?
Different activity.
Which would be more active? 2 gram zinc in 100 gram mercury or 4 gram zinc in 100 gram of mercury? Which would
Four,
act as the anode? Which would act as the tell me.
4 gram anode, 2 gram cathode.
Yeah. The higher the concentration of zinc would be having higher activity and lower the concentration. Therefore, how to write down this, how to represent this metal electrode, electrode concentration cell using this metal, just whatever may be the metal you are using, you just convert into amalgam. Zn within bracket they put as mercury, Zn mercury. If you are using lead electrode concentration cell, lead amalgam, the concentration will be different. And those when having higher amount of the metal in the amalgamated state would be the anode, the other would be the cathode. I think you understand the one concept, the concentration cell of the electrode. Therefore, whatever may be the electrode, you can make use of it, especially gaseous state and in the metal state. If it is a non-metal, it is highly impossible because it is not forming amalgam. Therefore, only in these two cases we are coming across the electrode potential shell. And for the electrode potential cell, we have derived the equation E is equal to 0.06. Temperature is given as 25 degrees centigrade. By N, the net number of electrons involved in the process, into log of the activity of the anode by the activity of the cathode. Don't forget, this is the equation. Making use of this, we can do problem shortly. And making use of this, if two activities are given, you may be asked to calculate what would be the concentration cell EF. Or in some cases, this concentration cell EMF would be given. The any one activity would be given, A1 is given, then you may be asked to calculate A2. Or A2 may be given, you may be asked to calculate A1. On the extreme case, and without giving the representation or any equation, they would give the concentration cell EMF, the activity of the anode, activity of the cathode. If these three data are given, they would ask you to calculate. They would ask you to calculate. Tell me, இருக்கிறது only 4 variables, E, N, A1, A2. Any one thing would be asked. Generally, if equation is given, they won't give you N. You have to calculate. then A1, A2 would be given, E can be calculated. Equation is given, E is given, A1 is given, you have to calculate N, then you are asked to calculate A2. Without giving any equation, they are giving the electrolyte concentrations, the EMF, and the two activities. Then it is possible to calculate the number of electrons involved in the reaction. Okay. And we will also having some introduction in the case of electrolyte concentration. And then keeping that electrolyte concentration as such, we will do some problems with the electrode concentration cell. Then go for the electrolyte concentration cell. I think today itself I will finish this one. And then we will move for the liquid junction potential. Then tomorrow class we will see the potentiometric titration application. Then go for the electrolytic shells. It will require 2 more classes. Nearly within 3 classes, I will finish this electrochemistry thing. So now we will see the electrolyte concentration cell. And the name itself, electrolyte concentration cell, means here due to the difference in the concentration of the electrolyte, the electricity is produced, for which we will take, say, nickel solution in one compartment, nickel 2 plus, and I am adding the nickel electrode. In another compartment, I am taking the same nickel 2 plus, placing an electrode. These two electrodes are externally joined, and a salt bridge is completing the electric circuit. Here, what we have seen the last discussion, the metal electrode concentration cell, you want this, the pure metal should not be taken. You should take the metal in the form of amalgam. And those metal having higher concentration would be acting as the anode, and the other would be the cathode. Here in this case, the electrolyte concentration is remaining the same. Now, what we are going to do is, we are keeping the solid electrode. Their activities are same in both the cases. Instead, here the nickel 2 plus, we are having one concentration C1. And in this compartment, we are having the same nickel sulfate or nickel 2 plus ion, but the concentration is different. Therefore, here electrodes are same activity. Temperature of these electrodes are also, that is anode and cathode, are same. But the third condition, the electrolyte concentration is different. Therefore, due to the difference in the electrolyte concentration, is there any passage of electricity? If at all it is passing electricity, and from which concentration to which concentration, higher concentration of electrolyte to lower, or lower concentration to higher, we have to see this. If you see this, you can easily construct the concentration cell with the electrolyte, and the higher concentration should be which side, and lower concentration should be which side. Looking into the representation, this is the electrolyte concentration or electrode concentration cell, whether electricity is produced or electricity is consumed. Looking into the representation itself, you can easily say this one. And for this, once again in this, the cell EMF E is given by E naught Nernst equation minus. Let us assume that the temperature is maintained at 25 degree into N into log of. Here if you write down this equation as nickel to nickel 2 plus 2 electron. This nickel 2 plus is, let us assume it is a C1 concentration, that is this side, anode compartment. Then what happened? The nickel 2 plus in the cathode compartment will take the electron, and the nickel is deposited. And I'm sorry, nickel solid. If you write down the net chemical reaction. This two electron gets cancelled. Nickel gets cancelled. And the reaction, and the net reaction is nickel 2 plus in the concentration C2 to nickel 2 plus to the concentration C1. Nickel C1. Therefore, what is the Nernst equation? E is equal to E naught minus 0.06 by N is equal to the 2 electrons you can easily furnish into the concentration of the product is C1 by the concentration of C2. And here the standard electrode potential value are the same. Therefore, the standard cell EMF would be 0 as we have seen in the electrode potential minus 0.06 into N into log of C1 by C2. And this E value should be positive, means this quotient should be, the quotient should be less than 1, it should be fraction. Then only log of that fraction would be negative. That negative, this negative will be becoming positive. Therefore, when will the quotient would be less than 1? C1 should be lesser than C2. Then the value is equal to 0.06 by n into log of C1. I'm sorry. இதை வந்து மாற்றி போட்டுருவோம் C2 by C1. Okay. We will have this discussion, then we will go for the other way. C1 should be less than. What do you mean by C1? That is in the shell written in the left hand side concentration should be C1 should be lower concentration, and the half shell concentration nickel 2 plus the right hand should be higher. Therefore, if it is the case, you can derive energy, EMF from this shell. Now the electrodes are same, but we are deriving and electrolytes are same, but the concentration of the electrolytes are different. Because of the difference in the concentration, we are deriving the EMF. This type of cells are called electrolyte concentration shell. That is, the cell is formed due to difference in the electrolyte concentration. We call it as electrolyte concentration shell. And in this electrolyte concentration cell, that electrolyte which is lower in concentration, from which electron is moved to another. Therefore, looking into this, in which compartment the electrolyte concentration is less, from that compartment, the higher concentration cell, that electron would be moving. Therefore, lower concentration electrolyte would form the anode, higher concentration would form the cathode. And when you represent this in terms of this diagram, you can look out which electrolyte comes first. You can identify whether electrode concentration cell or electrolyte concentration cell. If it is an electrode concentration cell, from higher activity to lower activity, and that would be higher activity would form the anode, other would be the cathode. If it is an electrolyte concentration cell, lower concentration, from lower concentration to higher concentration, the electron is moved. Therefore, lower concentration cell would be the anode and higher would be the cathode. That is one is just reverse to this. And now what is the equation to be used to calculate E? That is equal to 0.06 by n into log of C2 by C1. C2 is the concentration in the cathode, C1 the concentration in the anode. In the previous electrode, P1 by P2 or A1 by A2. A1 in the anode, A2 in the cathode. Just inverse. Don't confuse while working the problems. Under using this introduction to the concentration cell, now we are going to do some problems in the concentration. Then we will go for the next to one. Next to the detail layer to the sorry, you will see the concentration cell. Once again, concentration cell would be once again be given here two types. What are they? We will see it shortly. Take down the questions. Calculate the EMF. Calculate the EMF of the shell at 25-degree Kelvin. At 25-degree Kelvin. K, potassium amalgam, 0.1 molar bar, K plus. No necessity of indicating the concentration of K plus potassium amalgam, 0.03. Whether the representation is correct or not, it is a shell representation. If it is a shell representation, which type of shell is there? Simple voltaic cell or is a concentration cell? If it is a concentration cell, it is a electrode concentration or electrolyte concentration cell. You can immediately say this one. Here, K plus activity is not mentioned, taking into be equivalent. Therefore, if it is equivalent, here potassium, their activities should be different. It is different. And the higher activity to lower activity, the electron is moving. Therefore, it is a correct representation of the electrode concentration cell. For electrode concentration cell, you are asked to calculate the EMF. EMF is equal to 0.06 by N into log of the concentration in the anode by the activity in the cathode. Don't forget this for the electrode. For the electrolyte, the concentration of the cathode by the anode. Don't forget it. Then you just simply put the value. And what is the N value? N value is equal to 1 electron. And log of activity in the anode is 0.1, here 0.03. If you put this value log of, you can convert into log of 1. Sorry. Log of 1 by 0.3, or for simplicity, we will convert into log 10 by 3. That is equal to, you can write this like log of 10 a by b, it is written as log 10 minus log 3. Log 10 is 1, log 3 is 0.48. You know, ask your calculator, it will give you the answer 0.06 into 0.52, or it is 6 into 10 power minus 2 into 5.2 into 10 power minus 1 equal to 10 power minus 3, orange 30 and 31.2 into 10 power minus 3. Sometimes, what is the answer given? Look at the answer. The answer they are giving in terms of volt means convert this into this a word. Convert into the decimals instead of writing this inside, write in the natural form 0.0312 volt. Otherwise, sometimes they may give the value in terms of millivolt. If it is given in terms of millivolt, this is nothing but the milli. Therefore, the answer is 31.2 millivolt. Therefore, which unit they are they have given the answer. Look out the answer and write down accordingly. I think you know the way of doing the problems in this. Now take down the problem for the homework. It's a homework problem. Calculate. Yeah, tell
சார்
me.
சார் இப்போ நம்ம
Ah,
இதில் எழுதிருக்கோம்ல சார் ஃபார்முலா
ah.
பொட்டாசியம் மெர்க்குரி அமால்கம் இதில் வந்து நம்ம ஆனோட் கேத்தோட் அப்படின்னு பிரிச்சுட்டு அதுக்கப்புறம் ஃபார்முலா போடக்கூடாதா இல்லை அவங்க கொடுத்தத டைரக்ட் நம்ம யூஸ்
நீ
பண்ணலாம்?
பிரிக்கணும்னு அவசியம் இல்லை. We have already derived that equation. We have arrived at the equation like this. Therefore, just substitute the value and whether it is correctly represented or not. அப்படின்னு பாருங்க. 0.1 to 0.03 activity. Okay, this is a correct representation of your cell. Therefore, this is the anode and this is the next one is the cathode. Here, activity of the anode, A2 is the activity of the cathode we have written. Just substitute, you will get the answer. Okay? Not necessary to draw.
Okay.
Net,
And
if you are asked to calculate what is the net reaction, you have to separate them and then add, then you then give the answer for that. And next question.
okay.
So take down the problem as a homework. Calculate the EMF of the electrode concentration cell. Sometimes they may give or may not give. Electrode concentration cell. Zinc amalgam. With the zinc amalgam C1 bar Zn2 plus aqueous bar zinc amalgam C2 at 25 degrees centigrade. If the concentrations of zinc amalgam are C1 is equal to 2 gram of zinc per 100 gram of mercury. C2 1 gram of zinc per 100 gram of mercury. Option A 0.09 volt. B minus 0.009 volt. Minus point C 0.009 volt. B 0.009 volt. This is a homework. Take down the next two problems. We will work out here. Then I will give you another problem as a homework to you. Take down the problem. Compute the activity of the LHS BB mercury lead amalgam electrode if the E of the shell is 0.009 volts and the concentration of RHS, you know LHS and RHS. RHS lead amalgam electrode is 2 gram of lead in 100 gram of mercury at 25 degrees centigrade. The cell representation lead amalgam A1, lead sulfate solution aqueous, and lead amalgam activity A2. And you looking into this, you can say that it is a electrode concentration cell. For electrode concentration cell, E is equal to 0.06. The temperature is given as 25. Therefore, I can put it as 0.06 divided by N. Number of electrons involved is 2 because lead sulfate, because oxidation here 0, it is plus 2. It is plus 2 and the 2 electron giving lead. Therefore, 2 electrons would be involved into log. This electrode concentration cell, therefore A1 by A2. And what is A2? Right hand side lead amalgam is 2 gram. Therefore, instead of A2, you put just 2 gram, not necessary to convert into a mole, etc. Because we are also going to give the activity of that another LHS in terms of the gram. And E is given as 0.094. Therefore, just multiply this and rearrange it, etc. அப்படி பண்ணீங்கன்னா என்ன நடக்கும்? ரீஅரேஞ்ச் எல்லாம் பண்ணீங்கன்னா ஒரு 2 இது தள்ளினீங்கன்னா என்ன கிடைக்கும்? 0.9, or we will convert it into this, then we will give this one into 2 by 0.06 equal to log of A1 minus log of 2. Log of 2 is equal to minus 0.3. And what is the value for this? This one, 9 by 60 into 2 into 30 into 3 by 10 equal to 0.3. Am I correct? This value is equal to 0.3, right or wrong? 0.3. Therefore, log of A1 is equal to 0.6. A1 is equal to anti-log of 0.6. என்னது anti-log of 0.6? பார்த்து சொல்லுங்க பார்க்கலாம். உங்க கால்குலேட்டர் யூஸ் பண்ணுங்க. 0.3 க்கு 0.48. I'm sorry. Log of 1 is equal to 0. Log of 2 is equal to 0.3. Log of 3 is equal to 0.48. Log of 4 is equal to 0.60. Therefore, anti-log of 0.60 is equal to 4. Therefore, A1 is equal to 4. What do you mean by A1 is equal to 4? That is 4 gram of lead dissolved in 100 gram of mercury. 100 gram of mercury. Okay. Then I have given 2 types of problem. Giving A1 and A2, you are calculating the E1, and I have given some exercise to you. In the third problem, we have given the E and the activity of one is given. You are calculating the activity of the another. And I have given a third type of problem. I have told you a third type of problem. Without giving any cell representation or net reaction, you will be given the activity of 1 and activity of 2 and the E value. Then you are asked to calculate how many electrons are involved in that process. Is it possible or not? Yes, it is possible. அப்படின்னு நான் உங்களுக்கு சொன்னேன். Right, Tana? If you want, you can also take down this as a problem and work out that one. Let's take down the problem. In an electrode concentration cell, in the left-hand side, that is the anode, 0.1 atmosphere gas is passed through an electrolyte. 0.1 atmosphere of gas is passed through an electrolyte. And 0.01 atmospheric pressure of the gas is passed through the cathode. The electrode is concentration cell. EMF is measured to be 0.3 volt. Measured to be 0.3 volt. How many electrons are involved in the net cell reactions? How many electrons are involved in the net cell reactions? Okay. Now let us wind up this section. We have worked out the possible questions in this section. Now we will see the concentration cell, electrolyte concentration cell, electrolyte concentration cell. The electrolyte concentration cell is once again subdivided into two. One is concentration cell without transference. Concentration cells without transference. What do you mean by transference? I think you know this one, transference. And another is opposite to this concentration cell with the transference. And the cell representation, looking into the cell representation, you can say that whether it's a concentration cell, if at all a concentration cell, whether it is a electrode concentration or electrolyte concentration. If it is an electrolyte concentration cell, once again you classify whether it is a electrolyte concentration cell without transference or with a transference. The cell representation itself, you will be easily separating these two. How to represent this one, and what do you mean by transference? Transference means the migration of ions, the migration of ions. Now we will represent a shell, concentration cell, nickel, nickel. And pure nickel electrode. And I want to derive EMF from these. And the pure electrode is used, and both are having the same electrolyte, nickel 2 plus electrodes are also same. How it is possible? It is stated that these two are pure metal. Then you can construct a concentration cell making use of the nickel 2 plus. Here, two different concentration. In the anode side, the concentration of the nickel should be how much? It is higher or lower than the cathode side. So tell me, anode side, the concentration is lower. Cathode should be higher, then only electricity will be produced. Okay. And what is the, which would be acting as a completion of this electric circuit? The salt bridge. While you are using the salt bridge, the ions or cations are moving from the anode to cathode, and the anions are moving from the anode to cathode. We have already seen. Ions are moving, I have told. Which ions are moving? Whether nickel ion, cation from the anode to cathode, nickel ion is moving from the, no, nickel ion would not be moving here. Equivalent amount of the cation present in the salt bridge would be moving towards the cathode. Here the liquid salt bridge is used. The same cell can be represented in another way. We have already said what is this? By separating these two solutions by means of the porous part or porous or porous glass. Now we are getting this in this way. Here the pure nickel, and it is nickel 2 plus. Here also nickel 2 plus, and lower concentration, and it is higher concentration. What happened here? And you joined here also, it is a concentration cell. But what's the difference between this concentration cell and this concentration cell? Here ions are moving from anode to cathode. Here also ions are moving from anode to cathode, and vice versa. That is anions from cathode to anode. But actual ions moving with using the salt bridges, the cation, anion present in the salt bridges are moving. But here, since it is a semi-permeable membrane, or it's a porous part, or it is a porous glass, through this porous part, just like the pores are present in our mud pot, இருக்கிற மாதிரி from which the water is slowly leaking out. So is called the porous. Here, that is the passage of the actual ions, nickel ions, and the counterpart, if sulfate is present, sulfate, are all passing across these porous slabs. Therefore, this cell, this first cell in which the actual ion would not be transferring, but instead of they represent the cations and anions from the solid bridges are transferred. Such a concentration cell is called concentration cell without the transfer of the original cations and anions. Transference means transport, the original transport, that is movement. Concentration cell with the transference means there is the original ions are moving. Therefore, we have to see whether these two are involving two different shell EM. Definitely. If a salt bridge is used, the same concentration cell would be having one EMF, the same for the same concentration of the electrolyte. If you are using a semi-permeable or the porous part, it is having another type of EMF. The value is different. The value is different. Therefore, what are the equations? What are the equations we are going to use, making use of this calculation is two types of equations we are going to use. A slight difference. That difference, if you make a note of it, you can easily calculate, do the problem in this one. And what is the general equation we have written for the EMF of the shell electrolyte cell 0.06 by N into log of the activity, or instead of activity, you can activity the anode compartment by the cathode compartment. Instead of, if activity is given, you should put its activity. Sometimes they may give instead of activity, they would give you only in terms of concentration. You know, the activity is equal to activity coefficient and the concentration. When the solution is going dilute, the activity coefficient is found to be going reaching 1. Now the non-ideal solution would be becoming ideal, and that condition, the activity can be replaced by the concentration. Therefore, in dilute condition, it may be replaced by concentration. For some other problems, they will give you the activity coefficient as well as the molality. Activity is equal to activity constant into molality. If both are given, you multiply R and M and put the value. R and M and put the value. If sometimes activity is directly given, substitute activity. Concentration is given, substitute the concentration in the place of activity. If activity coefficient and molalities are separately given, multiply it, it is becoming activity. This is the way. These are the three ways you will be made confusion by the question paper setters. Okay, and this here we have already derived for VOT. It is a EMF for the concentration shell. But it derived for whom? நல்லா பாருங்க, அங்க என்ன போட்டிருந்தோம்னு பாருங்க. We have drawn the diagram with a salt bridge. For the salt bridge, this is the equation. What is EOT? What is E is cell EMF? BOT means anybody. Anybody without a transference. Then what is the representation for E with the transference? EWT. EWT. Here, the Y, there is a difference in the EOT value and EWT value. Here, in the salt bridge, the movement of the ions present, the cation and anions, we have chosen the salt-bridge ions such that their transference, their speed of the mobility are all same. But in actual practice, whenever an ion is moving across the membrane, for example, a sulfate ion is moving from this side, anion to the cathode, and cathode to anode, and the cation is moving, say nickel 2 plus ion, from anode to cathode. Their speed are not at all equal. They are all different. Because of the difference, the EWT, there is one more reason is also there. Here the ions are very nearer to each other, and one ion is moving very fastly and another ion is moving very slowly. Due to this, across the membrane, across the porous part, there is a charge separation, electrical double layer will be formed, and this electrical double layer will create a potential as we have seen in the electrode potential. This potential, we call it as the liquid junction potential. The two different concentration liquid at this junction point, they, due to the difference in the ionic mobility, they would create a charge separation. That we call the liquid junction potential. That we represent as ELJ. ELJ. In the EOT, EWT, that is shell EMF without with transference, that includes the actual EMF as well as the potential developed due to this. Whereas in EWOT, without transference, the liquid junction potential is ruled out because of the presence of the salt bridge. It is not creating any the charge double layer separation. But without this salt bridge, but by the presence of the semi-permeable membrane, a potential is created that we call the liquid junction potential. Because of this liquid junction potential and because of the difference in the movement of the ions, this EWT value is different from EWOT difference. And the EWT value is calculated here using the same equation, N into log of the activity of the cathode electrolyte concentration and the anode. But one difference, here we are going to use the transport number of the ions. You know what do you mean by transport number? Transport number, or another name is transference number. Both are same. Transport number and transferent number are same. What is the transport number? It is defined as the fraction of the total current carried by the anion. Now let us take the total current passed is 1, of which 0.75% of the current is passed by the cation, means the remaining 0.25 will be carried away by the anion. Why there is such a difference? Because these two ions are having different ionic mobility. Why they are having different ionic mobility? It is another form of the discussion, another concept. The ionic mobility we are going to discuss in the case of electrolytes, electrolysis. We are going to discuss in the conductometric titration conductivity. We are going to discuss why the cations and anions would be having different ionic mobility. What are the factors which affect the movement of the ions? We will have the discussion that here is simply it is sufficient to have the idea that they are having different ones. Which fraction of current is carried away by one ion? the remaining current would be carried away by the anion. The transport number is represented by T. T for transport number of transients. The anion's transport number is T minus, the cathode is T plus, and this is a fraction of the current carried away by the anion. This is the fraction of the current carried away by cation. Therefore, T plus and T minus will be always equal to 1. Making use of it. Here, the transport number is present in between this one. Now you understand this one. What is the transport number? This is T minus, or sometime you would be putting T plus. When should you put T minus? When should you put T plus? There is a very simple, very little difference between them, and for which you should look into the end electrode reactivity. The end electrode reactivity. If you the end electrode reactivity or cathode reactivity itself, you can judge whether it is to put minus or T plus. Now let us consider the first simplest case, hydrogen ion concentration electrolyte. Now I think I repeat this one. These are the two equations you have to make use of it. Here this part would be the same in both the cases. Only difference is in the case of electrolyte concentration cell with the transference, you should put the T minus, the transport number of the ion or transport number of the cation, which should be for this, for which you have to look into the electrode, end electrode, that is the electrode present in the right hand side activity. Accordingly, you can put T minus or T plus. Now consider this hydrogen electrode concentration cell A1 bar H plus, A2 bar hydrogen gas, and platinum electrical contact. Here also hydrogen gas and platinum. Okay, here also 1 atmosphere, here also 1 atmosphere. Therefore, there is no electrode concentration, but electrolyte concentration, they are different. Therefore, cell EMF is due to this one. Suppose the hydrogen is having 1 atmosphere and this is having 0.8 atmosphere. Now, what are the EMF is due to? The electrode concentration difference as well as the electrolyte concentration difference. Both is simultaneously operating and so on. The scientists will make all the possibilities. In one more situation is there, but that situation is so far not studied. What is the situation? I will, if I am remembering, I will tell you at the end of this session. And here you take the reactivity of the end electrode, this right hand side electrode. What would be the reactivity? H plus would take electron giving, or 2H plus giving hydrogen gas. Therefore, this will be a 2 electron process will be there. Now, this end electrode is reversible with respect to what? That is, if at all undergoing a reverse reaction, it is reversible with the H plus ion cation. This is called the end electrode is reversible with the cation. If it is reversible with the cation, for such a type of concentration cell with a transport number, you should put T minus into the RT or 2.303 into RT by NF into log of the activity of the anode solution and activity of the cathode solution. Or temperature is given, these are all equivalent to 0.06. Here, what's the difference? T minus. Okay, I think you follow this. There is another kind of shell. Its end electrode would be reversible with respect to cation. Reversible with respect to cation. For example, if it is a reversible with respect to the cation, you should make use of the T plus in the place of T minus. For example, a calomal electrode or silver chloride electrode for silver, and it is dipped in KCl. Here also KCl solution activities, when activities 2. Here you have to take this one. What is the activity of this? Here what happened is silver chloride converting the silver Ag plus into Ag plus Cl minus. Now you reverse these. That is, the cell is, electrode is reversible. It is reversible with respect to anion. It will react with anion, giving back to this one. Therefore, in this type of cases, the cell EMF is calculated using EWT is equal to T plus T plus, and other things are remaining constant by N into log of activity of the anode solution by activity of the cathode solution. And if you remember this, you can easily work out the problems. And one question is already asked, making use of this one, whether the cell is what is called reversible with respect to anion, irreversible with respect to cation. If you want this, I will give you this question already asked in the CSAR examination. Write down the question. The overall reaction for the passage of one F of charge, 1 Faraday charge. That is 1 mole of the charge in Artham. 1 Faraday charge in the following shell, silver solid, silver chloride, that is silver and insoluble salt electrode, we call it as like this, dipped in KCl activity A1, and put only one single line. Sometimes single line would be there, or in some books it is given perforated lines. இப்படியும் கொடுத்திருப்பாங்க, dashed lines would be there. Single line indicates that it is a semi-permeable membrane. KCl, activity A2. And here the electrode is a metal electrode with this insoluble salt. இப்படி இருந்துட்டாலே உடனே நீங்க என்ன செஞ்சிடலாம்? The cell electrode potential, electrode is reversible with respect to anion. Therefore, T plus should be placed. அப்படின்னு சொல்லலாம். அதை எழுதி கொண்டீங்களா? Is given by within bracket T. T denotes the transport number. T denotes the transport numbers. Close the bracket, take down the option. T plus KCl activity 1 to T plus KCl activity 2. B option, T plus KCl activity 2 to T plus KCl activity 1. அடுத்தது எழுதுங்க, நீங்களே எழுதிருவீங்க. T minus transport number of this minus into KCl activity 1 to T minus KCl activity 2. And the third thing is T minus KCl activity 2 to T plus, sorry, T minus KCl activity 1. Here, what they are given overall reaction. What is the overall reaction? Here, the overall reaction can be easily given by you easily. நம்ம ஏற்கனவே கொடுத்துருக்கோம் இந்த ஆக்டிவிட்டி அதெல்லாம் ஒன்று கொடுத்துருக்கோம் ஞாபகம் வச்சிருப்பீங்க அதை பார்த்தீங்களா ஞாபகம் வச்சுக்கலாம் otherwise I will give you the clue and here this electrode this left hand side electrode at right hand side electrode are the same, therefore they will be gets cancelled in the overall reaction, but here this and this would not be cancelled. Here which is having higher concentration, which is having lower concentration. A2 is this cathode compartment is having higher concentration and KCl the right hand anode is having lower concentration. Therefore net reaction due to the mass of the matter would be transferred. Enga transfer aayirkum? K from the higher concentration, that is this cathode compartment mass would be transferred to the anode compartment. Therefore, what would be the net reaction? KCl from the activity A2 is transferred to KCl to the cathode anode compartment A1 because it is higher concentration, it is lower concentration. And it is whether it is a transference cell or without a transference. Without transference means this is the net reaction, that's all. This is the net reaction. With the transference means you should add the transport number. The transport number, whether I have to put a T minus or T plus, for which you have to find out the end electrode, which is with respect to a cation or anion, it is reversible. If it is like this, the metal and metal insoluble electrode, it is reversible with respect to anion. If it is anion, you should put the transport number of the cation, T plus and T plus. And this is the way you can immediately tell the answer. Therefore, which is the correct answer? The B is the correct answer. But for this hydrogen bar H plus activity 1 and H plus activity 2 and hydrogen gas and platinum. What would be the net reaction? Either இப்படியும் போடலாம் H plus போட்டிருக்கலாம். அப்படியே எங்க இருந்திருக்கும் higher concentration to lower concentration is the transference is there. Therefore H plus or HCl கொடுத்திருந்தாங்க, write down the HCl or HA2 or HA2 from which the matter would be transferred to the lower concentration cell, sorry, H plus A1 and HCl A1. And next it is a transference, transport is there or without transference, a single line is given. If it is a double line is given, you will write is correctly right. If it is a single line is given, you should include the transport number. And what about this reactivity of this electrode? H plus plus electron giving H2. It is reversible with respect to cation, therefore you put minus T minus is equal to T. This is the net cell reaction. This is the net cell reaction. Which question is already asked? If at all asked, you can just looking into the cell, you can easily say this type of reaction will be taking place.
Explain the previous one once again, please, sir.
Which one? T minus and T plus. For hydrogen concentration electrode. You want this?
Both hydrogen and KCl comparison.
Oh, KCl comparatively. Okay, we will take this KCl activity 2 in which a metal insoluble salt and a metal electrode is deep, and KCl activity A1 in which silver chloride is solid, insoluble. This electrode we call it as If silver alone is present, we call it as the metal electrode. If silver treated with its insoluble salt, it is called metal insoluble electrode. And here the activities, and here these two metal electrodes are same. Therefore, it is not, the cell EMF is not due to the metal electrode potential, electrode concentration cell. But the activity of the electrolytes are different. Therefore, here the EMF is due to the difference in the electrolyte concentration cell. Okay, in the electrolyte concentration, what is the net reaction that is taking place? It can be written like this, a single one, or you may be written a double one. Single line represents a semi-permeable state. That is, these two electrolytes are in contact with each other through a porous part or a porous glass. If you put this like this, what it says that no ions would be moving, no potassium or chloride ion is moving from this part to this part, but the ions present here would be moving. Here would be moving. That is, this called salt bridge. If salt bridge is there, there would be no transport of number. If no salt bridge is higher concentration to lower concentration, the ions would be moving very fast. Okay. Therefore, what is the net reaction taking place in this type of concentration cell? From higher concentration, always the cathode compartment would be having higher concentration, from which the matter would be transferred to lower concentration. The anode would be having always, anode compartment would be having lower concentration. This is the net reaction when there is no direct movement of the ions from anode to cathode to anode. That is, without transferent, shell without transferent, the net reaction is this one. This is the net one. For shell with transferent, just like this, what is the net reaction? As the matter changes, it is the same. A2 giving the KCl1, A1. But you should include what is the speed of the ions. Either T minus, you should include the transport number of the anion and transport number of the cation in front of this one. And how to find out whether you have to introduce T minus or T plus, for which you have to find out the cell reaction of the end electrode, that is this electrode. Ag chloride reacting, electron is coming from anode, it reacts to give Ag plus and Cl minus, therefore it is converted to Ag solid plus Cl minus. If the reaction is reversible, then Ag would be taking the Cl minus, giving this one. Therefore, the silver is said to be reversible with respect to anion. It's said to be reversible with respect to anion. If anion is involved, the transport number to be placed is the cation transport number. This is the net cell reaction for the concentration cell with the transference. And this is the net reaction for the concentration cell without the transference. This is for anion, cathode reversible with the anion. There is another concentration cell, say example, take HCl activity 1 and HCl activity 2. And here hydrogen gas is passed. Here also hydrogen gas is passed. Hydrogen gas is passed. Platinum is the contact, electrical contact. Here also electrical contact. Instead a double line, I have to put single line. Why I have to put a single line? What a double line indicates? What is a single line indicates? Double line indicates is a concentration cell without ion transference. Single line with ion transference. Whatever may be without or without, here the transport would be taking place from the higher concentration to lower concentration. Because the electrodes are same, they would be gets cancelled. at the end of the equation. Therefore, HCl higher activity to HCl lower activity taking place. This is the net reaction in the case of shell without a transference. With a transference means you have to give the transport number. Which transport number here I have to put? The last, this problem you have put the cation transport number. Here also whether to put the cation transport number or anion transport number, for which you have to study the cell electrode reaction. Here what happened is hydrogen plus would take the electron, giving half hydrogen. Now, if you reverse this, hydrogen is involving with, it is, we call it as hydrogen, and the end electrode is reversible with respect to H plus ion. The previous one, the silver electrode is reversible with the chloride ion, that is anion. If it is reversible with the anion, put the T plus. If it is reversible with the cation, put T minus. Therefore, here you have to introduce T minus, T minus. This is a cell reaction. In the case of concentration cell with a transport, with a transference. With a transference, you should include this one. Now, do you understand this one? Hello?
Yes, sir. Thank you, sir.
Okay. Tomorrow we will see the problems in these concentration shells with without the transport number. Then if the transport numbers are given, how to calculate the liquid junction potential involved in that concentration shell with the transference. What is the liquid junction potential? After seeing some problems in these two, we will go for the application of this using potentiometer. I think so. Tomorrow I will finish this electrode potential or electrochemical shell. And the remaining two classes, I think I will finish the electrolytic shell. And one thing I want to tell here, I told you, if I remember, I will give you another thing in which anything is not taking place. And what is that I have given? I am going to share with you is the EMF depends upon what are they, the nature of the electrode or activity of the electrode. And using this, we are preparing the electrode concentration cell and the concentration of the electrolyte. Okay. And another is the temperature. Using the temperature difference, no shell has been so far discovered. How is it possible, sir? Yes, it is possible if you have find a time or if you are going to do the electrochemical research, you can make use of it. This is the one cathode compartment. Let me take the nickel 2 plus ion, and this is the anode compartment. I am taking the same nickel 2 plus ion. I am placing a pure nickel rod inside it, placing another pure nickel rod inside it. Here I am connecting these two by using a voltmeter, and I am going to complete the circuit making use of this one. Here I have kept the activity of the both electrodes the same. Here the concentration of the electrode I am going to take, it is 0.01 molar. Here also I am going to take 0.01 molar. And the temperature, here I am going to vary the temperature. I am going to vary, if we vary the concentration of the electrolyte, we are producing some EMF in the cell. If you are going to change the temperature, then also there should be a change in the temperature. Change in the temperature would produce some EMF. But no book would be giving this one. How to make the difference? Separate these two, and here I am keeping it at 25 degrees centigrade. Here I am keeping it at 80 degrees centigrade. Keeping it at 80 degrees centigrade. First question. From which compartment the electron would be moving? From 25 degrees centigrade or 80 degrees centigrade. Whether they would furnish, if it is moving, it will release EMF. Is it possible to construct such a cell? And second question, what would be the name given to this cell? But it is not important for the CSAR. This is just for you. Okay. And the next class we will see the problems in the concentration electrolyte concentration cells, then liquid junction potential, finally the potentiometric titration application in the potentiometric titration. Okay, thank you very much.